In this video, we'll briefly talk about databases, specifically how to work with SQL Server 2005 Express Edition databases. But before we run, we need to walk. So we'll start out by talking about databases, what they are, why to use them, and how they're structured. And then we'll demonstrate how to create and use a SQL Server 2005 Express Edition database from within Visual C#. And finally, I'll demonstrate how to modify data that's stored in a SQL database. So let's start small. What is a database? Well, simply put, it's a structured repository for data. You save information in a database, you read the information from the database, you update the information, and sometimes you need to delete the information. The information is organized so it can be retrieved easily, can be sorted, can be grouped, can be related to other data, and thereby can be used to analyze information in a countless number of ways. So let's say you have a business and you want to keep track of customers. You could store customer names in a simple text file using Notepad. But the problem is that after a while there's so many names that it becomes unmanageable and you have to scroll through this long file to find the name of the customer that you need to follow up with. So you decide to store the names of your customers in an Excel spreadsheet instead, which works for a while, but what happens when you want to view all the purchases in the month of April for your top 10 customers? Well, I suppose that's possible in Excel, but it's not as easy as using a relational database management system, or RDBMS, like SQL Server. And this is just the tip of the iceberg in terms of benefits in using a real database over a text file or an Excel spreadsheet. It's probably the most easy way to understand it, though. Now, up to now, SQL Server was considered a high-end database server used in large companies to enable the management and the retrieval of relational database data. In SQL Server 2005 Express Edition, however, you can harness the power in the most simple applications that you can dream up. Now, I use the term RDBMS, or Relational Database Management System. This is actually a philosophy or an approach to designing a database that's analogous in some ways to writing object-oriented code, although it's very different. Different techniques, different goals, etc. But in relational database theory, you organize your data into tables that are related with other tables and so on. So you might dedicate a table for customer names and another table for order information. Now, you could just create one table that contains both customer and order information, but then you run the possibility of having redundant information when you have a customer that ordered twice. And then there's also the issue of data integrity. What if the customer called himself Bob on the first order and Robert on the second order? Or a better example might be if the customer moved. It would be difficult to determine that both orders were in fact from the same customer. So it makes sense to manage this information in separate tables. Now, there's really a lot of rules that were created back in the 1970s and the 1980s by the creator of relational database theory. And those rules are called normalization. And we're not going to take the time to go over the rules, but be aware that I've really just skimmed over this idea and you can find out a lot more on your own. In most cases, you can normalize a database with just a little common sense. Once you see it done a few times, it's going to make a lot more sense to you. You'll pretty much have the idea under your belt. So let's dig deeper into database objects. First of all, please take the time to read the document that I've supplied that accompanies these videos because it's going to have some additional information that will supplement what I say here. So we're going to start with the concept of a table. And a table is the foundational database object. A table consists of columns and rows, or rather records. A single column in a single row is often referred to as a field of data. The columns define the type of data that will be stored in the table, and the rows or records are the actual data. So we might have a simple customer table with the following columns: first name, last name, address, state, zip, credit limit, customer since, and so on. And we've probably left out a number of fields that should belong in there as well, but I think you get the idea. In order to maintain data integrity, we need to define more information about each column, such as the type of data that's going to be stored in that column. And in some cases, like for example string data, we're going to have to define the maximum number of characters in the string. We'll also need to define whether or not a particular record can be saved if it contains fields of information with null data. Now, what is data integrity? It actually takes several forms, and it's one of the major things that a relational database system will help you maintain. For example, we may not want to allow somebody to add data to our database that sets our credit limit field to $2,000, all spelled out, TWO, THOUSAND, and so on. What we want is a numeric number that represents currency, so we'll probably use a currency data type, and that'll exclude the possibility that somebody will spell out $2,000, because we can't add the words $2,000 to a currency value of 1,500 or so on. Now the same is true for the customer since field. We can see that we've defined that as a date data type, and so it should only allow date values, and state, for example, should only allow 2 characters. For example, TX for Texas, CA for California, and so on. Now moving on, we may want to allow a record to be saved to the database if that record doesn't include an address. But we may not want to allow a record that doesn't have a name, where the first name and the last name is missing, for example. That wouldn't make a whole lot of sense. So what we could do is define certain fields like address, state, and zip to be nullable fields. These fields do not have to be supplied in order for the record of data to be saved successfully into the database. However, if first name or last name is missing, the database can reject the attempt by the application or the user or whatever the case might be to try and save data into the database. This is in an effort, again, to maintain the integrity of the data in the database. Data integrity is, simply put, just an attempt to make sure that the data that's in the database is correct and meaningful and useful for the purpose of any applications that might use the data. Now finally, we're going to want to add one more column, and we're going to use this column to uniquely identify this row of data. We're going to call the column Customer ID. And this type of column is referred to as a key, or better yet, a primary key. Now why do we need a key? A key is a way to differentiate 2 customers, or rather 2 records that have the same name, for example. Now, while you may have 2 records with the exact same information, that has the same name, same address, and so on, one field of data should be used to differentiate the rows. And typically, you're going to want to use a numeric field for this information. And so we can set a special property of that column called identity, which will automatically number each record of data as it's added to the database, and we'll use that automatically numbered field of information for each record of data as its primary key, as what differentiates it from the other records in the database. The primary key is also used in order to relate 2 tables together. Now, in addition to our customer table, let's define an order table. So you can see here that I've defined 4 columns: order ID, order date, order amount, and payment type. Now again, I probably left out some important information, so for our purposes, we're just wanting to investigate how this all works. But in a more real-life scenario, we may need to include some more information here. Most importantly, we left out the information that allows us to determine who actually created this order. Now this is a real problem that we're going to need to address now. We need to relate a row from this table back to a row in our customer table, and the way we do this is with a foreign key. So here we're going to add one more column of information called customer ID. And now it just so happens that we named this field the same thing that we named it in the customer table, but we didn't need to. We could have named it anything we wanted to name it. However, to make things easier to understand, we wanted to name them exactly the same. Now, by creating an order record and including the customer ID, we can easily tie back any order to the customer that created the order. Also, we can easily tie back all of the orders ever created by this customer, tally how much the customer has spent with our company, and a lot more. Okay, so just to recap, we have a primary key in the customer table called customer ID, and we have another key, another field in the order table that we've called a foreign key in the order table. And so now it's possible to relate these two tables together. The primary key and the foreign key can be related together, thus making a relationship between these two tables. But from a database perspective, we still have a problem. If I were to delete a customer in the customer table, all of the associated orders that were placed by that customer would be what's called orphaned, which means that we'll never be able to tell who ordered those items. That would be a huge problem, so what we need to do is create a special object in the database called a constraint, specifically what's called a foreign key constraint between the order table and the customer table. And when we do this, nobody would be able to delete a customer before deleting all of the associated orders first. The database just won't allow it because doing so would violate the integrity of the data in the database. You cannot have orphaned rows. So that was a pretty quick overview, and I hope you can see now at least some of the concepts of what a relational database is. Relational databases help keep data structured and therefore easily managed. They reduce redundant data by splitting up duplicate data into its own tables, and it helps to maintain the integrity of the data, among other things. So let's now transfer this knowledge of databases into creating a SQL Server 2005 database. And then we're going to add objects like tables and fields and relations to the database, and then finally we'll add some data to it. Okay, so I've taken the liberty of creating a new project called Lesson 08. And I just want you to know that there's actually several different ways that you can go about creating a new SQL Server Express 2005 database, but I'm going to use a more project-based approach for this example. So with my project open, I'm going to right-click on my project and select Add, New Item, and from the Install Templates section, I'm going to select a SQL database, and then I'm going to change the name of the database to Lesson 08.mdf and select Add. Now, by default, it's going to pop open this data source configuration wizard. Let's not worry about this for right now. I'm just going to select the Cancel button. And then I'm going to double-click this file within the Solution Explorer so that I can open up the Database Explorer with my database already loaded in. Now you can see here that there's some files underneath the lesson08.mdf file that's loaded under the Data Connections node. And what we want to concentrate on are tables. And by default, there are going to be no tables in the database. But what I want to do is right-click and select Add New Table. Let's reposition a few things here so we can see the main area a little bit better. Now we have a designer surface where we can create a new table. And we're going to kind of be forward-looking and create two tables that will be eventually used within our RSS reader application. We'll create them again in the future, but just so we can have something to talk about, we're going to create a folder table and then we're going to create a channel table. Let's start with the folder table. So I'm going to put my cursor in this little box next to column name, and I'm going to create a folder ID, which I'm going to use as my primary key for this table. For the data type, I'm going to put my mouse cursor in the data type column, and then I'm going to use the little combo box and find the integer data type. And then I'm going to deselect allow nulls. I do not want this field to allow any nulls. Now, if you remember from a discussion a few moments ago, whenever you're creating a primary key, we're going to set a special property of this column called the identity property, which will automatically number each row of data or each record of data that's added to this table. So to turn on that automatic numbering, what we're going to need to do is scroll down in this Column Properties tab and find the identity specification And I'm just going to double click it. Whoops, I need to open this up. Great. Is identity, we're going to turn this to yes. Now there's some other things, identity increment, identity seed. Don't worry about those. Just leave them at their defaults for right now. And then I want you to select in the next row where we're defining columns, and we're going to create a second column called folder name. And this time you can see that it defaults to nchar10. What we want to do is place textual information and allow up to 50 characters and allow it to be nullable. So we're going to select this nvarchar50. We're going to turn off the null, allow null for right now. And that's about all we need to do with one exception. Right now, even though we have defined our primary key, we have not told the database that we intend for this column to be used for that purpose. So what we'll do is select this little button on our toolbar to set the primary key. And when I do, notice that there's a little key that's added right next to the folder ID column. I'm going to select the Save button on my toolbar, and it asks me to choose a name for my table. I don't want Table 1 to be the name of this table. I want something a little more descriptive. We're going to call this table Folder. Select the OK button. And now, as you can see in the Database Explorer on the left-hand side, a new table has been created called Folder. And I can even drill down and see all the columns that are related to this folder. Folder ID and folder name. When I select either of these columns, notice over on the right-hand side in the Property window that we can view properties about that column. Now, we can't change it here. It's all grayed out. But we can still see some information about, for example, the folder ID, whether it's an identity or not, and so on, the length, and so on. Okay, so we've created our first table. Let's now close this designer, and we'll just close everything. We'll go back to tables, and we're going to create a second table. Add new table. I'm going to do this a little bit quicker this time since I walked you through slowly the last time. And this is going to be a table that will hold the channels. We'll talk about this when we get to the RSS Reader application. But we want to make this an integer. I'm going to turn off nulls. And I also want to set it as my primary key. Our channel will need a title. So I'm going to go to nvarchar. And I want to change it from a length of 50 by default to a length of, let's say, 250. So that'll allow me to put up to 250 characters of data, of string data, in this column. And I also want to not allow it to accept any rows. I think I may have made a mistake in my channel, as I remember I didn't turn on the identity column. So I'm going to go back, go to my isIdentity property, and select yes. Now we'll continue on. Channel will need a URL. And once again, I'm going to use the nvarchar, but I'm going to change it from 50 to a length of 250. And I'm not going to allow it to be null. Or actually, in this case, I'll go ahead and allow it to be null. And finally, I'm going to need to create a foreign key back to the folder table because we want there to be a relationship between the folder table and our new channel table that we're creating. So folder ID, in this case, we want an integer, and we're not going to allow it to accept nulls. Okay, I think I got it right. So I'm going to select Save. It's going to ask me for a name. I'm going to call this channel and select OK. So as you can see, I now have a second table here with 4 columns defined. And we can move on to the next bit of business, which is to create a relationship between these two tables. Now there's actually several different ways that we go about creating these relationships. There's a straightforward way, and then there's a more visual way that we can do it. And I'm going to take the more fun visual approach for this first time. And to do that, I'm going to create a database diagram. So over here in my Database Explorer, I'm going to select Database Diagrams, and I'm going to right-click it and select Add New Diagram. It's going to say that it doesn't have one or more of the database objects required to use database diagram. Do you wish to create them? Select Yes. and give it a moment or two. And then it's going to pop up and ask for the tables that you want to add to this diagram. We want both of these added, so I'm going to select the Add button once and select it a second time, and then click the Close button. And now what you can see is kind of a visual view of the tables that I have selected, the two tables that are in my database. Now the way that you create a relationship between these two tables is really simple. All you got to do is put your mouse cursor over the first one, kind of in this gray area, and hold down and drop it in its corresponding primary key in the other table. And when you do, it pops open some dialog boxes. We could have used this dialog-based approach to create it in the first place, but I thought it would be fun to create a database diagram. But either way, we'd have to go through the same steps at this point. So it's just that these are filled in automatically for us. The primary key table on the left-hand side is folder, and the primary key itself is the folder ID. And then you can see over in the foreign key table, it's the channel table, and the foreign key column itself is the folder ID. That looks correct. Notice that it gave it a default name of fk underscore channel underscore folder. That looks good. We won't change that. I'm going to select the OK button, and I'm going to select OK a second time, and I'm going to save this whole project and everything, including the tables. And I need to give it a diagram name. Diagram 0 is just fine. And after it asks us all these questions, we should be in good shape now. Okay, I've expanded the data connections one more time to get back. You can see I have now my diagram, I have my tables, and I know that I have a relationship between those two tables. So the next order of business is to start adding data to our table. Let's do this. Let's first of all start with a folder, and we're going to right-click it, and we're going to select Show Table Data. And in the main area, it'll open what looks like a grid. Notice at the very top, we have columns, and what we're going to do is start typing in data for the rows. So folder name, we're going to call this first folder, and then I'm going to use my tab key on my keyboard, and notice that it automatically put a 1 in the folder ID for my first record or my first row of data. I'm going to use the tab key again because I don't want to mess with the folder ID. It's going to automatically number itself. So here I'll put second folder. And notice as I'm making a modification to a given record or given row, then on the left-hand side I get this little pencil that looks like it's editing, and that's what we're doing. We're editing or making a modification to the row. And once again, here we're going to third folder and so on. Okay, so we've added 3 rows of data to our database. Now, we can use these little navigational buttons here at the bottom. We can move to the first row, and notice the little arrow cursor goes to the first row of data. Notice that I can go to use these next buttons, and the next and previous buttons will let me go one at a time, or I can use this move to the last row of data. And I can also select move to a new row, so it automatically places me at the position where I can add yet a 4th folder, and so on. I can also just type in a number and hit the enter key on my keyboard, and it puts me to that row of data in my database. So I've made modifications to my data. If I want to change something and just, like, for example, make a small change to the folder name, all I got to do is just go to that row, type it in, and then click somewhere off of that row, or just use the tab key on my keyboard again, and that change has now been saved to the database. If I want to delete a row of data, all I need to do is select it here on the right-hand side, and then I can click the delete button on my keyboard, and it'll say you're about to delete a row. Do you want to permanently delete this? You won't be able to undo it. Select yes, and now we no longer have a folder ID of 3. You can see that it's gone. We have first, second, and fourth folder. Okay, so that's just generally how to navigate through a table of data and create and change and delete the data in that table. So we're in good shape. Let's go on to our channel. I'm going to take the same steps, show table data. Let's move some things around here so we can see everything. And we're going to start adding some data here. First title, we can type anything here for now. First URL, and we're going to need to give it a folder ID. Now let's see if we can use the tab key on our keyboard and what will happen. Okay, it says that no row was updated. The data in row 1 was not committed. The problem was that we cannot insert the value of null into the column folder ID. So what we need to do is use either folder ID 1, 2, or 4, because those are the only 3 folder IDs that we have in our folder table. So let's use folder ID number 2 and hit the tab button again, and notice that this time we're successful. Okay, so what's the chance that we would be able to change this to a number that's not in our folder table? Like 7. We don't have a folder ID of 7 in our folder table. So when I hit the tab button on my keyboard, it says that the data in row 1 was not committed. This particular problem is that the update statement conflicted with a foreign key constraint FK channel folder. Okay, so basically this again ensures data integrity. We can't create a channel because there is no associated folder ID of 7. So we have to use only a folder ID that's associated. We can use the number 4, and it's updated successfully. Now let's go ahead and do a couple more here. Second title, second URL, and a folder ID of 1, and a third title, third URL, and 2. Okay. Okay, so let's do this now, just for fun. We're going to go back to our folder table, and let's try to delete, whoops, let's right-click it and select Show Table Data. Okay, let's try to delete this 4th folder. So I'm going to select the Delete button on my keyboard, and it asks, you're about to delete one row. Click Yes to permanently delete the row. You won't be able to undo the changes. So right now it looks like it's going to let us, but then we get an error message that says, delete statement conflicted with the reference constraint FK channel folder. Okay, so you can see that in order to maintain data integrity, the database is not going to allow us to delete a row from the folder that would, in essence, create orphan tables, or orphan rows rather, in my channel table. At this point, you might get tired of hearing what I'm about to say, but we've really just scratched the surface of working with tables and columns and records and constraints with the SQL Server 2005 Express Edition database. And you might be wondering, what are we going to do with this data? How does it really benefit us to put all this data in the database? In the next couple of videos, we're going to look at how to enter and retrieve the data into the database using a Windows application. So we're going to be able to represent the data in a grid or in text boxes, make changes, and save them back to the database. This is when it actually all starts coming together and starts becoming a lot of fun. So just hang in there. We're almost to some things that will really allow you to create powerful applications. But we're going to stop here for right now. If you enjoyed watching this video, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one, aimed at all skill levels on many different topics related to C#, Visual Basic.net, ASP.net, and more. Thank you.